All right, let's take a look at how to interpret the slope and the x and y intercept of the vertical and horizontal intercepts in context of a word problem. So our slope is m. Our vertical intercept, that's our y-intercept, we're using the letter b. That's from that y equals mx plus b. And then I'm going to call our horizontal intercept a. So we're kind of looking at a graph. Put a line on here. This is your vertical intercept. And this over here is going to be your horizontal intercept. Okay, so picture-wise, that's what that looks like. Our interpretation of the slope is along these lines as our x variable, and so you would replace your x variable with what it actually is in words, increases by 1 unit. Our y variable is either going to increase or decrease by the slope value. So we would choose increasing if our slope is positive, and we would choose decreasing if our slope was negative. And then you always put the slope value in here without a negative sign. So it's kind of the absolute value of the slope. For our vertical intercept, the explanation is when your x variable is 0, okay, which is true, right? X is 0 here. Whatever our y variable is equal to b units. So this is really our b. And then similarly, the horizontal intercept, when our y variable is 0 units, and the x variable is whatever a is, units. So let's give this a try. We have this problem. A flight costs $10,000 to operate regardless of the number of passengers. Each ticket costs $127. The equation for the profit, y, in terms of the number of passengers, x, is given by y is equal to 127x minus 10,000. So our first step here is to interpret the slope in context. So our slope, let's figure out what that value is the number attached to the x. So in this case, that's going to be 127. All right, so our explanation here, so as x, and x is our number of passengers. So as the number of passengers increases by 1 person, okay, so increases by 1 unit, our y variable, so that would be our profit, the profit. And then we need to choose either increases or decreases. So since our slope is positive, we're going to use increases. So the profit increases by, and our slope value is 127, and our units here are dollars. So our interpretation would be as the number of passengers increases by 1 person, the profit will increase by $127. All right, let's look at our y-intercept, or our vertical intercept. So that would be negative 10,000. We'll write that down here. And our explanation is when x is 0. So when the number of passengers is 0, or maybe you write when there are 0 passengers. That works as well. The profit is, sadly, negative $10,000. Okay, so if you're strictly following this sentence here follows that format exactly. You could also write something like when there are no passengers on the plane, the flight loses $10,000. Anything along those lines is fine. Okay, and then let's look at our x-intercept. So to get the x-intercept, that happens when y is equal to 0, right? So here's where y is 0. So we should need to solve for that. So we'll do 0 is equal to 127x minus 10,000, which means 10,000 is equal to 127x. So we'll divide both sides by 127. So we get x is 10,000 over 127, and see what that comes out to be. So it's approximately 79. So x is approximately 79. All right, so we can work on our explanation here. So when our y variable, so when our profit is 0, The number of passengers is 79 people. Okay, now this seems like kind of a weird statement. We have a zero profit. But what that means is that's our break-even point. So if nobody gets on the plane, it's going to cost $10,000 just to operate that flight. We need to put 79 people on the plane in order to break even from that $10,000. Okay, so if you'd written something about the break-even point is 79 people, I would accept that as an answer. That's fine. Okay, but this certainly is, if you're following this process, should get you to a statement that an English professor might say is really awkward, but the mathematical interpretation there is fine, and that's acceptable. It doesn't bother me if the language is a little bit awkward, as long as you get the point across. All right, so let's try this last one. We looked at this problem in the previous video. We have $48 to spend on soda and chips. So we came up with a formula for that. And that formula was 6y plus 4x equals 48. And we need to be able to find this slope and y-intercept. So we need to solve this for y. So I have 6y is equal to negative 4x plus 48. Then I'm going to divide through by 6. And when I do that, what I get is y is negative 2/3 x plus 8. Okay, so now my slope is this negative 2/3. And we're going to look at kind of two interpretations for this. So one of those interpretations, we're actually going to just use this description here, and then we're going to talk about kind of what that means. All right, so our x variable here is the bag of chips. So as the number of chips increases by 1, I guess that's really the number of bags of chips increases by 1, the amount of soda packs that we can buy decreases. And the reason we're choosing decreases instead of increases, remember you have to choose one of these two words. The reason we choose decreases is because our slope is negative. So we're going to do decreases by 2/3 of a pack. We're measuring these guys in packs. Okay. And when you put the number in, since we wrote the word decreases, we drop that minus sign off of there. Okay, so this sentence certainly meets the criteria. You would get full credit for it. It seems a little clunky and awkward. So let's talk about what's really going on here. So what's really going on is that 2 packs of soda is equal to 3 bags of chips in terms of cost. Right? So if the soda is $6 each, 2 packs is $12. If the chips are $4 each, 3 bags of chips is $12 also. So that's kind of the exchange rate. If you're planning on using all $48, for each 3 bags of chips you buy, you have to buy 2 less things of soda, okay, or vice versa. All right, let's look at the y-intercept in context. So our y-intercept is this positive 8. So b is equal to 8. And our sentence is when x is 0, so x is the number of chips. So when we buy no chips or 0 chips, okay, we can buy 8. And our y variable represents the packs of soda, so we can buy 8 packs of soda. And that kind of checks out. So if you think about the soda is $6 per pack, 8 times 6 is 48, and that's how much money we have to spend. So that seems fairly reasonable. And then we need the x-intercept in context. So remember that the x-intercept is when y is equal to 0. So we're going to plug y equals 0 into this, into any of these. Well, I'll probably use that one. And then we can solve. So y is 0. So 6 times 0 plus 4x equals 48. So that goes away. I'll divide both sides by 4. And I get x is equal to 12. Right, so our explanation in context, we're going to say When our y variable is 0, then our x variable is 12. So we're going to just swap out x and y with what they really are equal to in terms of the problem. So when we buy 0 packs of soda, we can buy 12 bags of chips. All right, so these explanations are a little more freehand. They don't follow this exactly. You can always just follow this exactly and drop kind of the words in there. But you're also welcome to, as you get a better feeling for this and a better understanding for this, to kind of write the sentences in a way that sounds maybe a little more grammatically pleasing. Totally up to you, as long as you're conveying the right idea there.